In this video, we're going to continue on with our solving systems of equations. But for all of these examples, we're not just going to be looking at two linear equations. We'll be looking at all sorts of different equations. We solve them the same way. We graph both of them and we look for where they intersect. Just be aware that with new shapes that aren't quite as straightforward as lines, different sorts of things can happen. For example, if we consider a linear and a quadratic equation here, when we go to graph them, a linear equation, of course, is a line, and a quadratic equation is a parabola. Well, in some cases, those may never end up even crossing each other, right? The smiley face is way up here, this line's way down here. They're never going to end up intersecting. The most common case that we'll get with a parabola and a line is something like this. The line will cross through the parabola once on the way in, and then it'll have to cross through it again on the way out. We also have a very rare situation that shows up sometimes when we end up with one solution. So for example, if we have the parabola like this and then a line like this, the single intersection point would happen right there at the vertex. So we do get some kind of creative things, but as long as you graph both of them and you're kind of careful about what those graphs should look like, you can identify your pieces as you go. So let's try some. The first thing that we want to do here is to solve our system of equations by graphing. I'm going to do the very first one by hand, just a review of graphing parabolas to kind of help you out, and then we'll look at solving these systems of equations using the graphing calculator as well as Wolfram Alpha. And so we can come up with some of those pieces as well. When we start out with the first one, if we want to graph this parabola, remember that we said that when we were learning this, that if we could find the x-intercepts and the vertex of the parabola, it becomes fairly easy for us to graph them. To find the x-intercepts, recall what you do is you set y equal to 0 and you solve the equation that's left. So I have this equation here. This happens to factor pretty nicely. X minus 2 and x plus 2 and x minus 1 will get us the middle terms that we need. So if we solve that, x plus 2 equals 0, we get x equals negative 2 as one vertex, or as one x-intercept. X minus 1 equals 0 gives us x equals 1 as another x-intercept. And I can come on here and I can plot those points. Negative 2 and positive 1 are my x-intercepts right there. And that gives me 2 points. The next thing that I'd like to be able to do is to identify what the vertex is. The x-coordinate of the vertex lies on the axis of symmetry, and that's located at the x-coordinate of negative b over 2a. In this case, my a is 1 and my b is 1, the coefficients of the x squared and the x. And so if I plug those into the equation, I end up with negative 1/2, and I'm just going to write that as negative 0.5 to keep my life easier here. And then I want to find what the y-coordinate, so at x equals negative 1/2, that means that my axis of symmetry goes through here. And if you notice, my 2 points that I have for my x-intercepts are symmetrical about that line, so I'm feeling pretty good about that. Next, I'm going to try to find the y-coordinate for my vertex so I can actually plot a point on that line. What I'll do here, take the negative 0.5 and plug it in for x, so I'm going to have negative 0.5 squared. So I'm just going back to the original formula up here, negative 0.5 squared plus negative 0.5 minus 2. And if I evaluate all of that, this gives me a positive 0.25 minus 0.5, and a minus 2 gives me a negative 2.25 for a final point. So at x equals negative 1/2, or negative 0.5, and at y equals negative 2.25, that's a negative there, I end up with a point right about there on for my parabola. Why did you disappear? So I end up with this point. And then I can kind of sketch this in here like this, and up here like this. Graphing on my computer screen is hard. And I can come up with this parabola like that. The next piece that I want to do once I have this graph is go ahead and graph the line. So negative x plus 1. This is just a line, so I follow my y equals mx plus b rules. I plot the y-intercept first at positive 1. My slope, positive 1's up here. Ha ha ha. Here we go. Positive 1. My slope is negative 1, so we go down 1 over 1. And I end up with a line that comes through like this and down like this. And hopefully you can draw it a little straighter than I can here. but I end up with 1 point here and 1 point here where they intersect. This one down here happens at 1, 0. That one's pretty easy to identify. This one here, we got to be a little bit more careful, but it looks like it's about -3, 4. Now, as you can see, my graphs are less than beautiful here, so graphing using technology is not a bad plan. But you can also double, and we'll do that here in just a second, you can also double check both of these points by plugging them into both of the equations, so those both have to work. If I plug 1 in for x, I get 0 for y. If I plug 1 in for x, I get 0 for y. I need to do the same thing with the other vertex, or not the other vertex, but the other intersection point. So I can plug in -3 for x, and I should get +4 for y, and I can plug -3x for x and get +4 for y. And if you do that, that will work out, and you're welcome to go through that exercise. But for just kind of some consistency's sake, let's go ahead and try to graph these on our graphing calculator. So I've got my graphing calculator here. I'm going to turn it on, and I'm going to go into the y equals screen. So if there's any equations there, go ahead and erase them. This time, unlike last time, this time we want to graph both of these equations, and we want them both to show up on the same screen. So in order to do that, I'm going to plot one of the equations here on y1. So I'll do that, x squared plus x minus 2. And hit enter. That gives me my first equation. My second equation, I want it to be -x plus 1. Make sure you hit the negative down here. It doesn't like you to use subtraction there. We'll do -x plus 1, and there's my second graph. So I want both of them to appear on the screen. Again, you can use Zoom Standard, that Z standard on the Zoom button, to give you a regular graph. Mine's already in that mode, so here it is. There's my parabola, and there's my line, and notice it looks pretty much like my really ugly picture here. You can look at where these intersection points are here and try to recreate them carefully. The calculator will also give them to you directly if you'd like. Notice that there's this blue calc here. That means it'll do calculations based on the graphs that you're doing. So if you hit second in that trace button, it brings up the calculating menu. I'd like it to figure out where my intersection points are. So I can type intersect. It'll ask you what the first curve is. Notice it's on the parabola, so just click enter. It'll ask you for the second curve, and it's on the line, so hit enter. Then it's going to ask you for a guess. The calculator can only find one intersection point at a time, so just use the left and right arrows to move that little cursor down so it's close to where that intersection point is. Notice that it's saying that the intersection closest to where I was is 1, 0. If I want to figure out where this intersection point up here is, I go through the same process again. Hit second trace to get the calc menu. Choose option 5 for intersect. Make sure my first curve is on the parabola, my second curve is on the line, and then just arrow up so that you're close to where the intersection is. It doesn't even have to be exact, but this says the closest intersection's at -3, 4. So that did work out pretty well from my hand-drawn graph, and I was able to confirm that using the graphing calculator. So you can do that, or you can just look at the y equals screen and see where those intersect.